students, it's Mr. Bornheimer, and I wanted to come to you today just to kind of go over a couple of problems that you may be struggling with in chemistry. This is a chemistry video, and today's focus will be primarily on looking at the mole and looking at atoms and molecules. Okay, so if we want to go ahead and break this down. Okay, so here we go. We're going to go ahead and we're going to look at the mole. All right, when we're talking about the mole, we're not talking about the furry little creature. Even though furry little creatures are very cute, like this mole here, okay, we are not going to be talking about furry little creatures. We're instead going to be talking more about a number that is represented by 6.02 times 10 to the 23rd. Now, to give you perspective on how big this number is, if you had this many marbles, like the little marbles that you used to play with, and you'd have them, you know, in a circle maybe on the ground, and you'd toss one in and it would knock the other ones out, okay? If you've ever played marbles, that's how you play. They're only about the size of maybe the tip of your thumb, maybe not quite that large. If you had one mole of those, it would cover the surface of the Earth almost 50 kilometers thick. Okay, that's quite a ways. So when we're talking about a mole, we're talking about a very, very large number. And because when working with such large numbers, it only makes sense to work with numbers when we're working with something very, very small, like atoms and molecules. Okay, so atoms and molecules. So that's going to really be the focus for this presentation, is looking at the mole, atoms, and molecules. All right, if I have one mole of something, I have 6.02 times 10 to the 23rd of that something. It could be anything. For instance, if I had 12 donuts, and I know you can totally see the connection between chemistry and donuts, then that is 1 dozen. Okay, now see that this is 12 of something, and it represents this idea of 1 dozen. Well, the same idea is true here with the mole. 1 mole represents the quantity, 6.02 times 10 to the 23rd, something. For our purposes, because the mole is such a large number, we are actually going to be working with 6.02 times 10 to the 23rd atoms, which are very, very small, and molecules, which, though not as small as atoms, oftentimes, are still just as small. So let's just say that I had 1 mole of carbon. If I had 1 mole of carbon, that means that I would have 6.02 times 10 to the 23rd atoms of carbon. That's what that means. Now, also, if I had 6.02 times 10 to the 23rd atoms of nitrogen, okay, that would mean that I have 1 mole of nitrogen atoms. If I had, let's say I had 1 mole of water, okay, or that's in liquid form, H2O. It could be in either solid or like ice, or it could be liquid, or it could be gas like water vapor. But if I had 1 mole of water, that means I'd have 6.02 times 10 to the 23rd molecules of H2O. Now, notice that here I'm using the term molecules, which means that if I consider H2O to be a single unit, and I have 1 mole of that unit, then I have 6.02 times 10 to the 23rd molecules of H2O. Now, does that actually mean that I have 6.02 times 10 to the 23rd atoms of hydrogen and oxygen? Not necessarily. But it does mean I have 1 mole of water molecules. Now, let's say that I have 1 mole, or 6.02 times 10 to the 23rd, O2 molecules. Okay, and I wanted to know how many atoms of oxygen I have. Notice that I'm really asking 2 things here. Notice that this is a molecule. It has 2 or more atoms bonded chemically. But I want atoms. I don't want O2. I want just O for oxygen. Now I have 1 mole of O2. Okay? For this particular example, I want you to think about it as, let's say that O2 is represented by a person. Okay? Now, let's say that I have 1 person. Now, on this person, I have 2 arms, 2 legs. Okay? I have these things. Notice the numbers are different, 1, 2, 2. But I'm talking about something different here. I'm talking about a whole object here, a person, so I have 1 of those. But in that person, I might have 2 arms or 2 legs. Now, imagine for a moment, okay, that I were to have 2 persons. Well, how many arms and legs would I have total? I'd have 4 arms and 4 legs. So we see we can apply a similar concept here when talking about atoms and molecules. If I have 1 mole of O2 and each O2 has 2 oxygens, then in theory for every 1 O2 I have 2 oxygen atoms. So if I have 1 mole of O2, so in theory, take and multiply this by 6.02 times 10 to the 23rd, and I get a mole, then I would have 2 moles of atoms. And that's what we mean by stating how many atoms of oxygen I have. I would have 2 moles of oxygen atoms. Okay. This has just been a brief rundown on the mole. It is a number that is very useful for us because it takes very large quantities of atoms and turns them into numbers that are manageable for us. It is a very useful concept, and as we progress through chemistry, I think you will start to see some of its greater usefulness. I hope this has helped. Have a good day.